We present our system for building multiple coordinated spaces for effective immersive analytics through distributed cognition. Our system starts with user registering Vuforia image target with the system. Here, based on the image target, user is presented with overview visualization which provides an operating panel with data components, derived information, and different visualizations in our system. User can immersively interact with each object to visualize them using selected data components. We now introduce different visualizations provided in our system. First, habitat distribution of different species are overlaid on topographic map of Smoky Mountains. User can interact with filtering buttons using hand gestures or voice commands to hide or visualize habitat distribution of respective species. We also visualize habitat distribution of individual species using what we call holographic layers. Holographic layers allow user to move around in the physical space to observe and explore habitat distribution of species in a better way. Another visualization we present is edge bundle graph. It groups the data points of a single species and visualizes the connection as 3D edges arcing out of the screen. It is a tool to distinguish species habitats from each other and analyze cluster of habitat locations of a single species. We also present parallel coordinate graph, which highlights dependency of visualized species on more than 50 environmental variables using 3D curved lines arcing out of the screen. User can gaze over icons to show their descriptions at detail on demand. By interacting with each icon, user is presented with heat maps of each environmental variable. These heat maps are used to depict distribution of environmental variable in the Great Smoky Mountain National Park. To assist in better analysis, we provide interactions as combination of gaze, hand gestures, and voice commands. User can rotate visualizations using gaze and hand gestures to view them from different angles. Using voice commands, user can switch to scaling or repositioning of visualizations. This allows user to drag and drop visualizations into 3D desired subspaces and arrange them as desired for effective and immersive analytics. We now provide a sample case study to show effective usage of our system. Here, user first brings in data for habitat distribution of amphibian species and view them on topographic map. User also move around and explore distribution of individual species using holographic layers. To make better use of physical space around, user positions different holographic layers in the 3D space. This allows user to physically move around to explore and simultaneously compare habitat distribution of different species. User find this arrangement useful and thus may want to revisit it. Here user can save these preliminary results as interaction history using voice commands. Previous exploration allows user to identify spatial regions associated with species clusters. User classified sets of species with similar habitat distribution and visualizes them overlapping on top of each other in separate 3D subspaces. This will allow better grouping of species to understand their collective dependency on environmental variables. After grouping holographic layers, user also observes specific regions in Smoky Mountains with no observed occurrences of any amphibian species. This intrigues user to explore the reasons by using parallel coordinate graph and heat maps of environmental variables. User again saved these results as an interaction history. Next, user brings in parallel coordinate graph from overview visualization to understand correlation of selected species with environmental variables. User interacts with icons to show heat maps of important environmental variables for respective selected species or group of species. Close analysis of parallel coordinate graph shows that areas with high elevation and increased frequency of precipitation are not favorable for habitat of amphibian species, explaining these regions with no habitat distributions. Here, user again saved these results as an interaction history. Further analysis using environmental variables reveals comparable dependency of similar species on environmental variables. For example, user observes a group of species have positive relationship with environmental variable of available water supply above 25 cm. Another group of species highly rely on wetlands and soil moisture. On the other hand, some species are not found in regions with frequent climatic changes and high precipitation frequency. User positions heat maps of these respective variables orthogonal to group of holographic layers and confirms his results. Finally, user creates another history instance using voice commands to save results of his interactive analysis process.